Thank you, Jeremy. As you mentioned, I'm Derek Kultgen with Argonne National Laboratory, and today I'll just be going over the use of LabVIEW at our facility called the Mechanisms Engineering Test Loop, or METAL, as the government loves acronyms. Argonne National Laboratory is actually just about 30 minutes south of here. It's the first national laboratory. It was born out of the Manhattan Project when Enrico Fermi created the first sustained nuclear chain reaction under the at Chicago Stagfield under the squash courts. Currently today, it is the most diverse national laboratory from a research portfolio. The top left image there is actually the Aurora supercomputer, which recently broke the exascale computing boundary. Below that is the Advanced Photon Source, which produces some of the world's brightest X-rays for scientific research. And if that excites you, I'm sorry. My meager existence is that tiny red circle there, which is where the Mechanisms Engineering Test Loop, or METAL, is, which is predominantly focused on conducting research for the nuclear energy. So before I get into the kind of LabVIEW, just going to give you my little pitch on nuclear energy. It has been kind of a constant production over the years, but is experiencing a revitalization and interest level. And it's not hard to see why. It's one of our safest forms of electricity production. As we see in the graph, that's deaths per megawatt hour of electricity generated. The only thing safer than solar is. Unfortunately, solar has a really low capacity factor. So it really doesn't produce that much energy during this state of time. If we're talking about hospitals, data centers, all these critical infrastructure that needs power all the time, you're going to need nuclear, 92% capacity factor. So very little downtime with our nuclear power plants. A kind of another rock people like to throw at nuclear energy is they go, oh, what about the waste? What about the waste? You're producing all this waste. Well, you're breathing the waste from coal power plants right now, and natural gas power plants. So everything generates waste. The beauty about waste at our current nuclear power plants is it's not true waste. It's spent fuel. If you recycle that, which Argonne has a long history of recycling it, using a sodium-cooled fast reactor, you can actually use a lot of that quote-unquote waste stored at the power plants today and use it to create electricity further, really reducing the true waste that you'd have to store in a geological repository. So a lot of the issues with nuclear energy are either false or there's solutions to it. We just need to find an economic means, an competitive means to actually implement these solutions. And that's kind of where our team comes in at the Mechanisms Engineering Test Loop. We are a 750-gallon molten sodium test facility where our mission is to advance instrumentation and equipment for use in sodium-cooled reactors. Those of you who aren't familiar with nuclear energy, our current fleet is cooled by water. So there's a lot of advantages to going with sodium. One, being able to recycle that quote-unquote waste, and then also higher efficiencies and lower pressures, so inherently safe. So we have a small but dedicated team. We have about 4 test vessels that we can insert equipment and instrumentation into to provide a prototypic reactor environment. This facility goes up to about 650 degrees Celsius or 1,200 degrees Fahrenheit, and has about quite a bit of piping network throughout it. And we also host experiments. A lot of the questions we get is, well, what kind of experiments are you actually conducting in there? And the question is the answer is all of the above. We've demonstrated things that are more kind of science-y, looking into the more basic research in the left image there, which is the Thermal Hydraulic Experimental Test Apparatus, or THETA. Told you we love acronyms. And that's really just kind of looking at more thermal hydraulic phenomena of what's happening inside of the core through different transients and other scenarios. The center image is looking at developing upper plenum, or just above the core, demonstrating out different instrumentation, whether it's flow rate or temperatures or power generated. And the right one is just more of mechanisms. So sodium is extremely reactive. It will actually ignite in humid air and start on fire, explodes in contact with water. You can't really lubricate any mechanisms or any mechanical moving parts. Sodium is your lubricant, which it has the viscosity of water, so it's not a lubricant. So the right image there is actually operating gears inside a bath of sodium effectively to determine the longevity in that harsh environment. So that's kind of the background on the facility, kind of the scale of it from a mission standpoint. Now kind of more of what you may all be interested in, and that's the supervisory control and data acquisition, hardware and software behind this kind of ecosystem that we have at Argonne. We have they now discontinued this, but we have an IC3173, which is an industrial controller by NI. And that's kind of a high-level controller, which is kind of the overarching controller for 22 kind of loop process controllers, which some of this hardware was specified before I started at Argonne. So if you're wondering why did you go this route, couldn't tell you. I got to this project mid-construction, but they are effective. They have been working. And the reason why we have so many controllers with these 16 PI, each one of them can do 16 PID control loops. We don't have a functioning reactor on site. So to provide the testing temperatures, we rely on electric resistance heat. Well, to ensure that we don't rupture a pipe, we have to actually segment our piping system into individually controlled heater zones. So right now we have about 280 individually controlled heater zones with the capacity to go up to 342. And you maybe wonder, why do you need that fine resolution of control throughout your facility? Sodium goes through a phase change. It freezes at about 97 degrees Celsius. So if you can imagine, if you have a section of pipe here that's frozen, a section of pipe here that's frozen, and in between it's molten, if you start to heat that center molten part, it will thermally expand and eventually rupture your pipe. So you have to break out these sodium systems to accommodate that phase change and strategically kind of thaw and heat your system, hence the 22 controllers there. We have 16 what are called programmable automation controllers, or PLCs, or 6 of those, which actually trigger the solid state relays to energize and de-energize the heater zones. And we have some electric meters to monitor the current draw of each of our heater zones. And then about 11 CDAC 9189s throughout the facility to get higher resolution on our temperature, pressures, flow rates, etc. There's a couple pictures of some of the hardware. The PAC there in the red box on the left, all of our current transformers for the power meters in the center. So I shouldn't say all, that's a small fraction of it. And the blue box and the green boxes have the energy meters. There's about 10 of those total. And then the right image are those 22 Mini 8 process loop controllers. What's kind of unique about working with sodium is it is a metal. It's a molten metal, it's an alkali metal. So we actually have electromagnetic pumps and electromagnetic flow meters. If we go back to our right-hand rule from undergraduate, if we apply a magnetic field in a certain direction and drive current orthogonal to that magnetic field, we'll actually create a force on that metal. And so that's the basic principles of how our electromagnetic pumps work, which is awesome. We don't have any moving parts, and we don't have any contact with our working fluid, which is great because it's really reactive, likes to corrode stainless steel and start on fire. So to control those pumps and some of our blowers to cool the sodium at certain locations, we have a C-Rio 9147 with various I/O. And that's an image of that. Again, being an experimental facility, caught this picture kind of mid upgrade there. And there's also the support of it. When we do have a fire, it is very thick smoke. It's caustic. You can't use water. It'll go boom. So really our only mitigation is to pull the smoke out and let it burn itself out for the most part if it's a large enough fire. Small enough ones we'll try to put out ourselves. But the larger ones, we have this 30,000 CFM scrubber shown in the image there. And that's controlled by a Allen Bradley Compact Logix. We also have various other CDACs there to support experiments. as well as a glove box, a centralized DC power supply to provide power to all this data acquisition equipment, 20 kVA UPS to back it up, and various air conditioners and power quality meters throughout the facility. So all of this is integrated into our data acquisition and control system. Again, a lot of different hardware vendors, not just NI, a lot of different protocols from Modbus, Profinet, Profibus, all the industrial protocols there as well, all integrated together. And again, just some images of the hardware there, the HMI for that 30,000 CFM scrubber, it's PLC in the center. We also have some wireless technologies like a batteryless and wireless, which is that red box there. That's a gateway for that technology, which is kind of cool that it's batteryless and wireless. And then we also have various gateways to handle those industrial protocols to convert them from your serial bus to Ethernet. And then the green box there is just like a radio wireless gateway for current input and voltage input signals for devices that we want to monitor while it's being hoisted across the high bay in our overhead crane. So that's kind of the scale of the facility. I hope I kind of gave a good picture of the different hardware that we have to talk to and integrate with, and to make sure that we're capturing all the data that we possibly can. And so, not saying this is the gold standard, but it's just kind of some lessons I learned along the way of, this is the largest facility I've ever had to deal with. Before Argonne, I was at a subsidiary of the Lubrizol Corporation, where I was mostly just doing smaller kind of test rigs, and it was mostly just repeating the same kind of test rig along the line. So this was kind of my first large scale application. And looking back behind me now, with hindsight, number one was to get organized. And this I kind of found was using tag bus. Is anyone here familiar with tag bus at all? 5 hands or so. Okay. And then so those of you who don't, that's the back end of kind of the distributed control and automation framework that NI put together. Wasn't really a big fan of decaf. I'm probably just not savvy enough to really pick up on it, but I did like the back end that it used, and that was tag bus, which consists of tags, which are objects, a dictionary object, and then a data table, which just uses actually a benefit is it uses LabVIEW primitives, so just a cluster full of different data types. And so just the kind of workflow with working with tag bus is you create tags. It's an object with a few attributes, a name to it, metadata, a default value. All those tags together create a data dictionary, and then the actual numerical values or the Boolean values are stored in your data table. So that's where the actual useful information is, the actual value you're looking for. I'll get to some of the applications of the tag bus later, but as I mentioned, one of the attributes is having a name. You have to give a tag a unique name. It will give you an error if you try to duplicate something. The tag name I found is really to kind of provide an address of where you're getting that data from. And so I broke this out into basically having a colon delimiter and breaking out, my target. Everything basically just uses queued state machines or queued message handlers. So I have modules. So I would have my controller, then module, the data type that I was looking at. I kind of grouped things together in relatable groups. So it'd be like, heater group for all the different heaters, or pump group. And then the point would be the actual descriptor of what I would say an operator would be familiar with. So, vessel 1 pressure or something like that. So everything before that was just kind of like, where can I find where this value is coming from? And then the final kind of point is the descriptor for it. If you do get into tag bus after this presentation, you found that it's useful, there's some applications. My biggest mistake was not leveraging the metadata. You can basically use the JSON schema and get a lot of useful information by leveraging the metadata attribute of your tag. I pretty much just did it as a description. So for instance, it would be like, I'd have a heater zone, and then my I would have a heater zone for the electric meter, and the metadata was just amps. Nothing great, but if I could go back, I would have been much more descriptive, told you which electric meter was coming from, which I/O terminals, etc. But again, wasn't that smart and just gave a really basic description. Since there's not many of you kind of familiar with the kind of tag bus workflow, I gave some examples of some names of real tags we have. The controller's name is Mike. The module name is EM4900, which is all of our electric meters. It's a single precision floating point data type. The group I put it in is heater read-only, or abbreviated heater RO. And then the actual kind of more descriptor point of what an operator would be searching for, and that's dump tank vessel zone 1. And there's multiple heater zones to this large vessel. It's about an 800-gallon vessel. So just a quick default value. The real value in tag bus is in the, if I can put on my pointer here real quick, is the filter by tag function here, this guy here. You can basically take a string search and filter out the tags you're looking for. So we have about 5,000 read-only tags and 5,000 read-write tags that we have. So how do you get the tag value you're looking for? You just type in the descriptor of what you're looking at. So the top one would return one single tag, and that's the very top one you see here. If I get rid of that one, the number 1, I'm going to get back 6 tags, and that's what you see zone 1 all through zone 6. If I get rid of it further, I'll get all of the tags associated with that electric meter module. If I get rid of the module name, I'll get all the tags associated with that controller. And so you can really hone in on the data you're looking for when you have a huge set of data coming from multiple different vendors, different controllers, scattered throughout a campus, and kind of get it quite quickly. So that's kind of the workflow. Once you find the tags you're looking for, you then use that dictionary object that will tell you what index value it is in your data table, and that's how you extract your actual raw value up here. So we get our tags that we're looking for, get where they're actually located in our data dictionary, index it out in our data table, and that's where it's stored. So that's kind of how I got organized. Not saying it's the gold standard, but I've found it useful and has been quite effective. Lesson number 2 I learned with a large facility and kind of more of a corporate setting, being a national laboratory, is when I got there, I had a colleague and now friend who has a similar sized experiment, well, about a third of the size or so. He goes, don't mess with IT. They're not going to be helpful. Stay on your own private VLAN or your own LAN. Do everything with your own switches. Don't mess with them at all. That was the worst advice I ever got in my life. Our IT has been extremely helpful. I kind of went in, I didn't know anything about IT before, really. I could set an IP address on, CREOs and CDACs, and that was about the extent of my knowledge. So I quickly learned there was limitations to following, my colleague's advice. And so I reached out to IT, said, hey, I'll take you out to lunch, once a month or so. I'll buy. I want to know everything you know. I want this to be a better facility. And so he got me he helped out. He got me in contact with colleagues, and this was kind of our topography of our network, that we're now we're a VLAN inside of Argonne's greater network. Have ability to have up to 255 IP addresses. We have maybe about 150 or so now just for this facility. We're able to then leverage the wireless network at Argonne. So I said, hey, I have some wireless devices. And they're like, I want to put up my own wireless network. And they're like, yeah, that's not going to happen. For security purposes, no way. But they were able to work with me on a solution. So they said, what we can do? Tell us the MAC address of the devices you want. We'll assign it a static wireless IP address. We'll get a firewall conduit into your VLAN, and boom, now your wireless devices will have access to your metal network or your metal VLAN. And so, they've been great. They've worked through all of the different issues of remote control off-site. They said, the Department of Energy requires multi-MFA, and you have to do MFA through your smart card. We all have, badges with a chip on it. So they set up, hey, we can set up a virtual machine, have it require your smart card login, and that will be your Bastion host, and that's how you'll get into um, your your private VLAN within Argonne's network anywhere in the world. So that's great. There's also been a lot of benefits by doing this. The fact that you now can integrate with Active Directory. So when an operator logs into the HMI or our LabVIEW executable, if they want to change a value, they have to actually log into Active Directory. So just with your normal LabVIEW functions, you're able to communicate with your organization's Active Directory. And if those of you who don't know what Active Directory is, it's where all of your organization's usernames and passwords are stored. So now when someone goes to operate this facility, they log in using their normal career account credentials, and now I can actually determine who's changing what parameter and log that in a digital format, like a digital logbook. We're able to span across multiple buildings. As I mentioned, this is more of like an ecosystem. Argonne's kind of like a synonymous with a college campus almost in the way it's laid out, where it's spread across multiple buildings. We're also able to leverage the greater resources of the organization to be able to integrate with enterprise-grade hardware like the network area storage system you see there that's located at our data center. So there's just been a huge benefit. I really, I don't care on the size of the organization. I think working closely with IT and not staying on your own little private island will be beneficial, even from the point of getting notifications on your phone or from your system. So if you have a test system, we integrated with Argonne's emergency notification system. So when you get like, oh, there's a tornado warning, or hey, watch out for slippery roads, it's snowing, that same emergency notification system all the employees get, we're able to then use for our system to send us, hey, you're getting too hot or your flow rate's out of whack. And so by leveraging that system, we're able to get push notifications, text messages, et cetera, all by leveraging existing infrastructure. So my other lesson then is, you've gotten organized, you're now best friends with IT. And I think the lesson number 3 here is you have to get your data out of your kind of LabVIEW environment and send it to the web. But I've also used LabVIEW tools. So I found LabVIEW web services to be a really great tool. So there's a few resources that we have for deploying extended reality. There's Tag Bus API, which I'll kind of go over an example. We also use the LabVIEW web services to integrate with our computerized maintenance management system. So now your HMI is not just looking at sensor data, they can pull up asset data. Okay, well, what's this pump's manufacturer model name? When's the last time it was serviced? Who performed the service? What parts did they use? We also have now a web interface as well by leveraging the LabVIEW web services. In fact, we use GWeb because I'm not a HTML, JavaScript, CSS expert. I found GWeb to be a pretty cool tool as well, especially for the price point. Again, that data, that web service is an executable that runs on a server that communicates with our CRIOs via the STM library or simple TCP messaging library. And then if those of you who aren't familiar with web services, the methods do require global variables. So I use FGVs, but you can use global shared or your traditional global variables to get data from your top level VI that's communicating with everything in your web service to actual web service methods. So now I'm just going to go back with the Tag Bus API. As I mentioned before, we can search a string and get all the tags we need, right? And then get all the values we want. I incorporated that into a API now with Tag Bus. So someone can enter the URL of the server hosting this web service and literally provide the bus, so whether they're looking for a read-only or read-write value, and then simply their tag search. And it's a JSON schema for an array of string. And so this way, I now can allow someone, a of any operating system, any programming language to access our data just by using this API, and they can search in plain English what they're looking for. So you can see this one here. This one was the URL searching for pressure, and boom, it pumps out the pressures of all of our pressure transducers. It provides the value, the actual tag name, and then the metadata. As I said before, I was not very, didn't have very good foresight on the metadata. I just said, yeah, it's a current input. What else do you want to know? So found the web services very helpful, combined with tag bus being able to do this. And that's been able to then transition into using GWeb, NI's product there of, again, not a web developer, but was able to, you're able to manipulate the HTML they generate for you. And so some kind of cool features we did with that, with developing our own quote unquote intranet site, was able to embed our Matterport. So now someone goes to this web interface, they can physically walk around our facility like it's a Google Maps tour. They also allow custom JavaScript functions. So I put one together to actually get the URL string that someone's coming from, so that you can actually dictate how your web interface is going to look. And if you're not, anyone, am I just rambling on about GWeb? Everyone use GWeb? Not many? Okay. So a few, yeah, GWeb. A lot of people hated the NXG environment. This GWeb is actually just kind of, I think, how NI tried to make some money off of the big loss of NXG. But the GWeb environment is kind of NXG basically. But yeah, it's the LabVIEW environment. You make, again, queue message handling capabilities using the HTTP requests. But all of the images you're shown here, that's all just GWeb using that web service to grab data now, so that we're into a browser interface now. And so yeah, the development environment, I actually like it quite a bit. I think it's got a lot of pros compared to the traditional LabVIEW environment. Okay, so again, we now can get our data to anyone we want to. Anyone can get our data because we now have an organized fashion of our data. We have a network that we're allowed people in and out of, and we have an API that allows people to intuitively, grab the information that they're looking for. So now let's put it to work outside of just, your traditional, I would say like an HMI, or just, okay, big deal, dude, you put your data from a LabVIEW executable to now a web browser, who cares? This is kind of putting it more to work. And having this API, I think, Andy was talking about how things are a team development, right? We can't work in a silo. I feel like a lot of times, in the test and development environment, we kind of just, hang out with our own testing people. We like hardware, we like developing software. But really, to have innovation, you have to branch out and work as a team. And I feel like this API, having an API and getting your data out to other people within your organization can be extremely helpful. It personally has been for me. One example that we've been able to leverage is extended reality. I'll go over some of the demos that we've had there. We've been able to help other scientists develop better machine learning methods now they can, they don't have to get our historical data from us. They can just grab it as they needed. We've also demonstrated with the image there is we have a group on site that just does prognostics, which is basically trying to help nuclear power plant operators determine what is actually failing in their plant or the remaining useful life. So their claim to fame is that most machine learning techniques will tell you of an anomaly, right? They'll be like, hey, this is not normal. Okay, great, but that doesn't help me that much. I still, as a human, have to go in and try to diagnose, determine what that anomaly is and what's causing it. Their software, ProAid, that's developed at Argonne National Laboratory, can actually discern whether it's instrument failing or equipment failing or both, and give you the probability of what it's going to be. Because they basically combine machine learning with the actual physics of the plant. So they're incorporating mass balance, energy balance into their software. And again, they used our API. We did some failures. We closed we would close off choke flow artificially to see if they could detect it, see if that equipment was failing. So that has been a great working relationship with them. We've also expanded to cybersecurity now too. Of anyone familiar with the Stuxnet? A few people. So basically, we also have cybersecurity teams at Argonne who do research on cybersecurity and trying to have a robust cybersecurity, especially when we talk about next generation nuclear power plants. The current ones out there are about the gigawatt scale, monster installations. A lot of the ones coming out now are small modular or micro reactors. So you're going to have a bunch of smaller reactors, and you can't have the same team, per reactor. Otherwise, your economics don't work out. So you have to have the same size team looking over a bunch of smaller reactors. Well, how are you going to achieve that? You're going to need digital technologies, and you're going to have to make sure that they're secure. So we've been working with them, demonstrating some kind of Stuxnet potential vulnerabilities. And again, they're leveraging our physical facility, leveraging our tools to create more innovative features in the cybersecurity space. The extended reality one I was kind of heavily involved in. And as someone who's a hands-on person, enjoys actually, getting my hands dirty, welding, cutting and grinding, all that fun stuff. I really like this one because, and kind of took ownership of this because one of the things that someone could throw a rock on nuclear energy on is the costs, right? I can give you data after data that it's one of the safest forms there is. I can tell you it's got the best capacity factor. It's extremely reliable. I can tell you the waste is not an issue. In fact, you could take all of the spent fuel in the US and put it in a football field about 10, 12 feet high. And that's all it takes up. Again, you're breathing our hydrocarbon waste now. But someone could throw a rock at costs. It does take quite a bit of people to run a nuclear power plant. I think with a natural gas power plant, on-site people, maybe about 25 to 40. It's about 500 at a nuclear power plant of equivalent size. So when we talk about costs, that's an issue. Obviously, construction, mostly held back by licensing, has been an issue with costs. So said, how do we take LabVIEW and combine it with extended reality, kind of demonstrate the future worker? And so there's a spectrum to extended reality. There's assisted reality, which is the left image. You can see me with the hard hat and a boom. Is anyone familiar with the assisted reality? Couple in the back there, two over there. So basically, it's a boom that goes just below your peripheral in your eye. It's just a different form factor of an Android device. That's all it is. In the boom there, just below your eye, is a little tiny screen. On the band is where the actual processor and Android OS resides. It can attach to a hard hat or a little band that they sell. But it basically enables hands-free interaction with a mobile device. I'm going to mention you got the screen just below your eye there. So if you look in your peripherals, you can see a pretty decent sized screen. There's also augmented or mixed reality, which is typically used with a Microsoft HoloLens in the center image, or a lot of the augmented reality can be with a tablet or phone. And then MetaQuest on the right for either augmented virtual reality or virtual reality. One kind of use case we said was the nuclear industry is very much a paper trail organization, kind of archaic in that sense. They still use a lot of analog instrumentation, a lot of paper trail. So this was going over a digital procedure now. So this is a combination of using the LabVIEW web service, LabVIEW G-Web, and the assisted reality device of now someone can actually go through a digital procedure. So in the what you see in the screen there, they can actually see in their peripherals as they're going through, while still, again, having full use of their hands. So they can go through steps. Okay, step one, make sure the temperatures are there. They're streamed live to their tablet screen there, what the actual real-time temperatures are. So they can verify that. They don't have to go through a traditional HMI. They don't have to ask an operator. It's right there in their peripherals. So that was kind of one use case. The next one is a little quick video. This was a combination of LabVIEW web service using that API, G-Web, assisted reality, and our computerized maintenance management system. what you're going to see is basically there's a camera attached to this assisted reality device. The operator is going to scan a QR code on an asset and bring them to a GWeb page. On this GWeb page, on the right, they could access the asset information on that. So they don't need to go trying to find that nameplate of, hey, what's the manufacturer serial number on this thing so I can look it up in my maintenance management system. They scan the QR code, they can actually access this through GWeb and get what all the asset information is. Or what they can do also, as you'll see in this demo, is get, again, real-life data of how that asset is performing. And so this one is specifically a heater zone. You scan a little QR code about the size of my thumb with an onboard camera, brings you to a GWeb page that's interfacing with our web service, tells you the asset number, the asset kind of name there, gives you the current draw of it, the current PID percentage call for heat. It's giving you a graph of the actual process variable. So it's a heater. We're interested in temperature. It was drawing, a few amps there. Tells you the set point. So we're also interfacing with the read write. So an operator can see like, wow, it's supposed to be at 300 degrees Celsius, the black line here. So the red line is the present value. It's only 280 degrees Celsius. What can I do to manipulate to see what's going on? So I think this is a demonstration of how you can really enable your operators in your, and then again, here's the asset information. You can really, assist your on-site personnel perform their job more efficiently. This one hits home for sodium fast reactors. So sodium is optically opaque. The current nuclear reactor fleet has the ability that once they shut the plant down, they can actually look in this pool of water and see equipment, right? And so they can see what's going on inside of the core once they're shut down, obviously, because it's just water. Sodium fast reactors don't have that. It's going to be optically opaque. They can't see what's going on. And so this one leverages the LabVIEW web service, some of our CAD, PTC's ThingWorks, as well as PTC's Vuforia. And this demonstration is technically mixed reality using a HoloLens. And it's that gear test experiment there. You can see my colleague Teddy and I handling that with the crane there to insert it. Again, once this gets inserted in sodium, you can't see how it's operating. Well, you can use mixed reality to prevent, to then have physical buttons that they can press with HoloLens, showcase what's actually happening inside of that device with the gears spinning, actually illustrate the vibration data being displayed there, and so that they can actually give your operators a better visualization of what's going on, of what they physically can't see. With a combination of mixed reality and instrumentation. This one demo thought was kind of unique when we're talking about, I'm going to circle back to that, you're going to have multiple tiny reactors, one control room. Who knows where that control room could be? Maybe it's someone's apartment, or how do you make a virtual control room? And so this was the LabVIEW web service with the GWeb pages insert into a MetaQuest. And so just using the MetaQuest built-in browser, you're able to access the web page, that GWeb page, and actually get live data inside of your MetaQuest. So, in this way, you can have the screens as big as you want, however many screens you want. Do you want to spin around and see 10 screens, or however you want your operator interface to be? Again, all pulling live data there. And we're adding the ability to control the API now as well. So this could be their new control room using a headset. This one is web services plus our CAD plus reality capture, which, if you're not familiar with reality capture, basically in about 30 minutes you could scan this entire room and have millimeter resolution details of the size of the projector, the size of the room, the tables, chairs, etc. It's just a laser that spins around in a bunch of different angles. It's actually quite cost effective too to do our entire facility. I think it was like $5,000, and basically able to do reality capture and replicate the entire facility as built in less than a day into now put into a CAD environment. We also then reached out to a consultant who does Unreal Engine work. For those of you who are gamers, thank you. the Unreal Engine 5, and so they're able to take our CAD data from reality capture, replicate that in a virtual reality environment, and then combine that with our web service. Let's see if I can get to my off that. Come on, work for me. I don't think it's going to let me do it, but basically, I'll kind of let it play through. I think I have a little bit of time. So then they were able to then, with a data sculpt toolkit, so this is just the reality capture. It's going to go through the Matterport, which was just a plug and play. It's not great yet, putting Matterport directly into Unreal Engine 5. If you're familiar with Matterport, you can see that this is not a typical Matterport, but it was literally just drop in, and it's not terrible. But basically what you're going to see later is they're taking our live data and actually changing the color of the facility based on the temperature real time. So you can see this is what's called absolute temperature. So it's taking our two extremes, our freezing point of sodium and the max facility operating temperature, and coloring the entire 200 plus heater zones color based on their actual temperature. Pop-up labels of what the actual zones are called for an operator. They can click on those little call-outs there to determine what the temperature is. And so then there's just another environment there where be able to get relative temperatures, and that's going to take basically the maximum and minimum available, so your color scheme is a little bit more visible because it's a sharper gradients. So I'll just quick let it roll through that. As you can see here, this is where it's the maximum now is what, 328 degrees Celsius, and the minimum, we have some frozen vessels up there, 27 degrees Celsius. Again, if you're looking at a huge multiple plants that are very complex and multiple sites, this is a quick visualization that, yeah, everything seems to be normal. And so that was kind of the motivation behind that one. And then this one just goes through like the user defined. They can actually go through a historian, so they can pull up historical data and actually see it play through a transient. I got a couple sneak peeks of what we're working on. A language model combined with our web service. So as I mentioned, the tag, you can search the tag with just plain text, right? So now you can take an audio operator. So we're in the process of putting speakers and microphones throughout our facility. So an operator can go, hey, what's the temperature in test vessel 1? And it's going to respond with the actual temperature, because all it's going to do is convert that query into text, search the correct tag, use some language, large language models, pull out the correct tag, and then it's going to search our tag bus, pump out the correct the process value to it. Always looking to pursue our digital twin. If you caught my interview or talk with Sam for the SaaS, we talked a little bit about digital twins and how one thing we're always working for is trying to get closer and closer to a perfect digital twin. A digital twin is a periodic table. These are all the elements that make up a digital twin, and that's why if you have listened to Sam's podcast there with the SaaS with me in it, is I say that we'll probably never reach a full-blown digital twin. There's just so many elements to it. But one thing we're going to focus on is incorporating the physics of the plant into it, so that we can kind of predict where it's going to be going. And then the last one was a motivation from the extended reality, is that QR codes are kind of limiting. The fact that you have to go search around for the QR code to try to find, the asset information. And if you're in a plant that even the size of ours, you have thousands of assets. If you're at a nuclear power plant, you're going to probably have 1 million of assets. So the thought was, if you could take reality capture of your facility, get it how it physically is built, put that into a virtual reality environment, right? You're going to have to follow along with me a little bit here. So you put your CAD into a virtual reality environment like we just showcased. You have your assisted reality device with improved position detection, like IMUs onto it. So now you're not getting just really specific GPS location, but you're kind of getting the pitch, yaw, and roll of the person's head where they're looking, okay? So now you feed that positional data into your virtual reality. You now have a virtual person. You now know what asset that person's looking at. And you can feed them data based on what they're looking at. They don't have to scan a code because they're a virtual They have a virtual person in the exact replica of your virtual environment. You know what their position that they're at and what they're looking at, what asset, and you can feed it right to their boom. So that's another thing we're kind of working on. Thank you so much for your attention. I hope you enjoyed it. I hope I didn't ramble too much. I'd like to thank the GDevCon NA presenters. This is fairly old work. I tried to present it at NI a week before, back when they still allowed third parties to present. So appreciate all the organizers putting together such a unique and special event like this. And any questions?
Can you actually elaborate a little bit on the digital twin concept? What that is in a nutshell.
Yeah, it has varying degrees, I guess. In the kind of, if you're looking at it from holistically, it'd be like every aspect of it is digital. So that if you were to, let's say, change something in your plant, you then update that through your, whatever your CAD is, your product lifecycle management or something, that then is updated throughout your process. So I would say an example would be, so say I have a simple loop. It's got a pump and a valve, right? I know I have all of the information on that pump. So I know at a certain speed, it's going to create a certain amount of pressure, right? And if a valve has so much opening, it's going to create so much pressure drop or something like that. Well, if I incorporate the actual physics into it, right, in a separate machine that's running the physics on it, all the calculations of going, okay, at this speed, it's producing this much pressure, and so therefore I know my pressure drop through all my lines, and it's going to go through this valve and this pressure drop. I don't need to run it up to, 50%. If I'm at 25%, I don't need to run it up to 50% speed to determine what the pressure drop is going to be. I have the physics now. I can predict, I can calculate what it's actually going to be because I have everything built into a model of what the physical facility is. So I know my pipe bends, I know the valve information. And so you don't need to guess or get just purely data driven. So if you're looking at data driven results, they're maybe 80% accurate and they require large amounts of data. If you do more of a digital twin based approach where you're incorporating the physics and data, you need much less data and you're 95% accurate on average or so. So that's kind of an operational aspect. I would say also from a life cycle aspect, it's if I swapped out that pump for a different pump, I then incorporate my CAD model into that, right? So now my CAD model incorporates that new pump. It should, if you set it up correctly, it will then seamlessly update your physical model, right? So now I have a different pump in there. It has different characteristics of pressure versus, speed of the shaft. And so now my model is completely updated. If I swap on this pump for that pump, I don't need to guess. I can actually predict because I have all of the physical characteristics of it.
Question is a bit higher level. Is it a twin of a device, a control system? Is it a twin of you? I'm trying to understand.
So it could literally be anything. You can get as granular as you want it to be. So there are digital twins of just a pump. So it's literally just taking the physical asset and putting it into a virtual environment because now you can do a lot more, right? I'm not gonna mess around with my plant as much as I can with the digital model. There's no consequences in the virtual environment. So that's sorry.
Yeah, that's right. Thanks for your presentation. I did have a question about cybersecurity. If you go back to the slides that you had about your network stuff, presentation. I'm kind of curious what cybersecurity IT is suggesting you use inside your network. I see a lot of VPN information and two-factor authentication coming from the outside of VPN. Using cybersecurity as a network, encrypting data between points and machines and controllers, things like that.
So from once, I guess, just a high level look, if you're on Argonne's campus, you cannot get to our network. So like there is a built-in, firewall within a firewall kind of thing. As far as inter-target communication, like between different CREOs and different servers, currently it's just raw tag bus, so it's just a raw string, there's no encryption. We have done some work from a more research standpoint doing quantum key distribution for a way to actually send in your key to your encryption. But currently we don't have any kind of inter-target security because we're pretty protected just in our VLAN. You could plug in a device into one of our switches, it won't recognize you and won't let you communicate. So.
What sounds like
Correct. Exactly. Yep. So that's that way. Like I said, we're pretty secure as it is. So we're not encrypting from target to target.
Have you thought about that?
No, I think ultimately you have to go that route because again, someone could maliciously connect to a vacant port and try to find their way in eventually. That is something we're trying to work towards.
First off, you're talking about this was awesome. It's a really cool application. So I'm not sure who or where you tried to present it, and I think I would love to help make that happen. So if NIW or whatever, like this is an awesome application. Happy to make that happen. I had a few other questions, but among them, GWeb, you talked about it a lot. I'd be curious to understand if there are any specific requests or asks, gaps, or features that you and your experience using GWeb this type of application have. Off the top of your head, I'd love to hear it now. If something else I got flying, it's fine too. Just know I'm very interested in understanding if you have any insights or asks pertaining to your use of GWeb.
I mean, I feel like if anything would just be like better help resources. Maybe that's about it. I actually don't have much bad things to say about GWeb. Again, maybe that's just because I'm a terrible HTML person, but I don't really have anything terrible to say about it. Maybe just documentation wise to help get started. I kind of fumbled around a bit at first. But if you have a web development background or understand, I think, servers better than me, should be fairly straightforward.
I'll offer that's kind of a recurring theme we get from GWeb users is like they're pretty happy with it. And then people are like, well, what's planned for GWeb? It's like, well, what do you need? So let us know. Also, a more random question on your periodic table of your digital twin. I was just curious, you had gamification listed down there. What are you trying to gamify in this context?
So there's a lot of research that's been done about people who, I'll give a quick example. We got a person who does physical security. So they'll do research on TSA and stuff like that. And so I talked with that guy, and they said basically the better TSA inspectors are gamers because they're kind of used to identifying different colors. Like it just comes inherently natural to them. And so the same kind of thought with gamification goes for operating a reactor, is that video games are a kind of a really intuitive way. Once you understand video games, how things work, you can kind of pick up on other interfaces quite well. And can you leverage gamification like that to not only attract the new workforce? A lot of the workforce in nuclear is old, retiring, or dead. So, hey, facts. So, a lot of that's gone. So how do you, the next generation's coming up around a digital environment, around all these devices. So how do you engage? How do you get them interested in nuclear energy? And that was kind of our thought, was you have to speak their language. We talk about all the time with you're going to show up, to this kid who's had an iPad since kindergarten, and hand him a paper to fill out form. It's but.
All right, thank you very much, Derek. We're going to have a short break.
Thank you.